Today's lesson is 4A.3, side, 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 angle, side, and HL. What we're going to start learning in the next two lessons are shortcuts for saying that two triangles are congruent. In the last lesson, we learned that to say that two triangles are congruent, or any two figures, we had to check all the sides and all the angles. For triangles, that meant we were checking 6 things: 3 sides, 3 angles. What people noticed over the years was that triangles were special and that they could find shortcuts with triangles to say that they are congruent. So they cut it down from 6 things that you need to check to only 3. And you just have to memorize the 5 shortcuts that there are. And there's only 5. And the first one is side, 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 or SSS. It basically says that if 3 sides of one triangle are congruent to 3 sides of another triangle, then these triangles are congruent. I can go ahead and see that these two triangles pair up. The hash marks, remember, mean that we are congruent to each other. So the 1 with the 1, the 2 with the 2, the 3 with the 3. And since they all pair up, I can write a congruent statement that says triangle ABC. Remember, the first triangle you cannot name incorrectly. It's your choice. The second triangle, you name it in the same order that you named the first. And so this one's name would be DEF. And of course, my reasoning would be by side, side, side. Okay, so now I'm only checking, are all 3 sides equal in both of my triangles? All right, then someone noticed that there was another shortcut, which was called side angle side, SAS. It says that if 2 sides and an included angle. Now let's stop just a minute and talk about what it means to be included. Included means that I am between both of the sides. So for my angle to be included, it must be between the 2 sides. So let's take a look here at angle A. Notice it is between the 2 sides of this triangle ABC. I also like to think of included as I'm going to go to lunch with my friends. I want to be included and sitting at the table with them, and I want to be right between them so that I can hear both of their conversations. I don't want to be left out. And of course, if they are congruent to 2 sides and an included angle in another triangle, then the 2 triangles are congruent. So take a look here at this triangle. There's my angle, and here are my 2 sides that are right next to that angle. I could almost start with the 1 hash mark side, go to the angle, and then go up. They would create that angle A. If you can take the angle and you can do this and your hash marks are on the angle's sides, then you have side angle side. You have side angle side. So I can go ahead and say that the first triangle, and just to be cute this time, I'm going to go ahead and call it triangle CAB. And so now I have to really pay attention. The second one's name has to be EDF. And if I were to explain why, I would say by side angle side. Okay, just like the letter A is in the middle, the angle has to be between the 2 sides. All right, the last shortcut that I want to talk to you guys about today is called hypotenuse leg or HL. This is a special um, shortcut because it only applies to my right triangles. So if the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and the leg of a second right triangle, then the 2 triangles are congruent. So for this one, you need a right angle. So these are the 3 things you need, because remember I said the shortcut's always 3 things. You need 2 right triangles. Then what you need to see is you need to see a hypotenuse. You need to see a hypotenuse equal to a hypotenuse, and you need to see one of the legs equal to the other leg. Now, if the legs were to switch, let's say this blue was here, then they would not be HL. So they need to be the same corresponding leg. That's the only trick. So I could try to trick you with saying instead of this leg, make it this one. That is not HL. But this is HL. Uh, if you were to look at it, it would look like something that is incorrect, and I'll come back to that in the next video. Okay, so those are our first three shortcuts. Let me go ahead and zoom out a little bit so that you can see all of them. Side, 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 angle, side, and HL. Remember, HL, once again, is a special one only for right triangles. You cannot use it on an acute triangle like we see in these two pictures. You cannot use HL there. All right, let's go ahead and take a look at a couple examples. Are the triangles congruent? How? And if they are, we're going to go ahead and write a congruent statement. So we're going to say that they're congruent, and we're going to say by side, 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 by side, angle, side. That's the how. And then, of course, we're just going to name the two triangles. That's my congruent statement. All right, so the first thing I noticed in example 1 is that I have one pair of equal sides. I have a second pair of equal sides, and I notice that none of the angles are marked. The tricky part here is this side right here in the middle. That side in the middle is in both of my triangles. It creates my triangle on the top and it creates my triangle on the bottom. That means that they are congruent to each other per the reflexive property. So my answer for this one would be yes, the triangles are congruent. They are congruent by side, 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 and I would name them P, Q, R for the top, and then for the bottom, let's see, P, Q, R, P, S, R by side, side, side. All right, let's take a look at this at number 2. The first things I notice is that I have 2 and 2, so those two sides match each other. I have angle U and angle W with the same arc mark, which means they are equal to each other. And then I notice their trick once again. UW is in both triangles, so by the reflexive property, it has to be equal to each other. And now what I see in both triangles is two sides that create this angle U, right? Two sides that create this angle U, two sides that create this angle W. This is side, angle, side. So I'm going to go ahead and name them. Triangle TUW is congruent to triangle VWU. Remember, U and W need to be in the same place because they are equal to each other. U and W need to be in the same place. I started in this corner here and went up. So I had to start in this corner and come down to the W. That's how I knew how to go. And of course, we already said by side, angle, side. I have just a couple more. All right, let's take a look at number 3. The first thing that jumps out at me on number 3 is I have my right angles. I have my right angles. So I'm going to go ahead and I'm going to look for my hypotenuse and I'm going to look for my legs. Well, here's my leg and here's my leg, and they both appear to be the shorter of the two legs. If I look at them, my other legs are here and here, and they're the longer of the two legs. So of course, the longer would correspond to the longer and be congruent. But I don't see my hypotenuse. Oh, wait a minute. It's hiding right here. And of course, per the transitive property, it has to be equal to itself because it's the hypotenuse for both of them. So I could go ahead and say triangle EBC is congruent to triangle E, B, C, D, oops, I forgot the D. D, E by H, L, because I have that right triangle. All right, let's look at this last one, example 4. And I know you're seeing example 5 and you're thinking, Miss, why'd you say last one? That's because example 5 is your exit ticket. And I'm just going to show you a couple of things so that you guys can go ahead and get your exit ticket correct. Okay, so here I have two sides that are equal. I see that right away. And then I see over here, LN is equal to MO. LN is equal to MO. So I'm going to go ahead and mark that. Ooh, okay, that's kind of tough. Let me see. Let me grab my highlighter and mark that. LN is equal to MO. The whole thing. Okay, that's better. I don't see any sides. The triangles that I think they're talking about are these ones, right? These ones are the ones I think they're talking about. Oh, wait a minute. I just noticed something. Look right here. That side is in both of those triangles. That side is equal to each other. I have one pair, two pair, and then of course I have three pairs of congruent sides. So I can go ahead and say, oops, I didn't want that color. I can go ahead and say triangle, let's say NOL is congruent to triangle ONM by side, side, side. Okay, so just be careful. One hint that I would tell you, mark your picture. You're going to need a separate sheet of paper and you're going to need to be drawing these down and you're going to need to be marking your sides. Color helps. Color helps a lot, but it just allows you to do it faster. Okay, so let me go ahead and just give you some hints on this last one. I see the right angle, so I might be thinking HL. That's the way I go right away. But please make sure that you do mark your picture. That you do mark your picture because I do notice that. I do see that I have a leg, and they seem to pair up to each other. And then, of course, I have this side this reflexive side that they both share. So what I'm going to do is I'm going to say, yes, these are congruent. And I'm going to go ahead and name them for you. I'm going to call it FGJ is congruent to triangle HJG by, and that's what I want you guys to decide. How are they congruent? Is it side, side, side? Is it side, angle, side? Or is it HL? Those are your only three options. Good luck.